Hello everyone and welcome to the Cyber Back to School. My name is Uros Babic, Security Architect in Crayon, Microsoft Security MVP and Microsoft Certified Trainer. In this session, today we will discuss about Azure Network Security feature, and you can see in agenda we will discuss about network security groups, how is network security group is implementation. We will discuss about application security group and actually what is difference between network security group and application security group. We will discuss about the service endpoints and private endpoints, Azure Application Gateway, Azure Firewall Manager, how we deal with the web application firewall, how we deal with the Azure front door and ExpressRoute. But the first, we must discuss about defensive depth. Why? With the Microsoft point of view, how we implement perimeter security is very important to understand how we think of security in layers. The first, we must lock down the perimeter first and then work with the way looking down each layer. The more work and cost and a lot of hackers has to advance to get valuable information, to more likely are they leave and you alone. But I'm a security engineer. I'm using the perimeter security feature to block some network traffic from my perimeter network resource. And like how I can set up DDoS, Denial Service Protection, how I configure and maintain firewalls, and I can use dedicated routes and network appliance to protect my network. And during this session, we will discuss this possibility. Very important to understand this process with the point of view defense of depth, because this approach includes many control to design how to mitigate a lot of risk in organization with the point of view primary security control, when primary security control fails. And this design actually should consider how likely the primary control to fail to potential organization with different approach of risk and effectiveness of additional control. And I will explore in this slide, try to explain defense of depth design of Azure services and capability in order to help securely manage and monitor cloud data in infrastructure of managed services. This Microsoft design actually operates in cloud service with the security of core and provide a lot of capability. The first is, of course, physical security. After that, we have identity and access, very important to implement cloud identity protection with conditional access policy, with the Azure policy, but we must use definitely privileged identity management. That is not good idea to have a lot of global admin role. I'm, for example, security admin, I'm exchange admin, and for tomorrow I have a task in 3 hours to finish this. And the great place for that is actually privileged identity management. But each service in Microsoft Azure is built with security in mind from the ground to host infrastructure, application and data, and all service actually is designed spanning your data application, virtual machines, network perimeter related policy, and physical security with the data center. and including how the data sensor and system run Azure and are architected and operated to control, you can apply definitely a part of defense of their security management. And the more company actually digital reside is on operation and corporate network in the cloud and the personal device, it becomes obvious that parameter only based security. I give you some example like I don't know, firewall, DMZ, virtual network. That is no longer adequate, but adoption of software-defined network and software-defined data, for example, technology-defined network segmentation, concept to more be granular, like here, and network microsegmentation actually, because microsegmentation is a way to create a security zone in data center, and Azure deployment to allow isolate workload to protect individuality, and security policy in virtual environment can be assigned, for example, with virtual connection that we move application if network is reconfigured, and that is very important part. But best practice is actually to adopt zero trust approach, zero trust strategy, based of user, based on device, based on application identity. And actually, we have here elements of this all control. For example, the first is how we understand network security group can be used for the basic layer in OSI models in 3 and 4 to access control, for example, between Azure networks, subnets, and internet. The second layer is, second example is application security group. What we define to grant network security policy, for example, based of my workload, how we centralize application instead of explicit IP address. And of course, most important is also web application firewall, and Azure firewall can be used for more advanced network access control that require application layer support. A lot of other example like local admin password solution like Labs or third-party privileged identity access management can set strong local admin password and just-in-time access. We discuss in a lot of my session about just-in-time access. I have access with my virtual machine via port 389 RDP or actually SSH in 2 or 3 hours. That is the principal last privilege actually. Third party in many cases offer microsegmentation approach that many enhance network control to apply zero trust principles to network control with the legacy asset. And how we actually explore virtual network security, we will discuss about that. We can define some key terminology for Azure networking because Azure network virtual network, that is a key component of Azure security services. Azure network infrastructure enable securely connect Azure resources with other virtual network, and we are using VNets as a that is actually logical isolation of Azure cloud network dedicated for my subscription. And I can connect actually my virtual network with on-premise network. That is very important to understand because Azure support dedicated WN link connectivity, one for your on-premise network and Azure virtual network with, for example, ExpressRoute. And that is good example because link between Azure and your site use dedicated connection. I can share this approach with you. because that is very interesting to understand. Actually, I can zoom to better for better visibility. Yes, and the link between Azure and my site, I can use some dedicated connection here. Does not go over the public internet, of course, but if my Azure subscription application, for example, is running in multiple data center, that is, I can use, for example, Azure Traffic Manager to route requests from the users intelligently across instances of my application. And I can also route traffic to service not running in Azure if they are accessible from the internet. That is very important to understand, and how we deal with this example. And of course, you have a lot of different layers. I discuss with a lot of my session about container security, but Microsoft Defender for Cloud Plan 1 or 2 with SQL, and Microsoft Defender for Cloud for Storage and Azure Information Protection is how we protected our data, how we labeled our data, and provide layer approach and multiple levels of our protection. The next is actually how we understand hub and spoke topology in Microsoft Azure. That is actually a very important part because hub is actually a scope of virtual network in Azure. That is a central point of connectivity with on-premise network. And good example, I can define my Azure Bastion or Azure Firewall VPN gateway in order to connect with my virtual networks with the peering with the hub, and can be used to isolate workload like this. And I can use Azure Monitor for diagnostic to control all my log and telemetry of data, and for tunneling between Azure Firewall and my REST subnet in virtual machine. I can connect my on-premise network with actually my virtual network with the Bastion firewall and gateway, and other connect with this approach. And that is very important to understand, because we have very clear topology with Microsoft Azure, and when discuss about network security, that is actually most important thing. And I define some plan like this. I can use regular peering between two virtual networks in the same region in East US, or global peering between East US region with the virtual network 1 and West Europe. And you can see in this actually diagram free virtual network with different subnets between virtual network 1, that is actually 10.1.0.0/16. I define subnet here for my virtual network, and I also defined two other subnet in order to show peering between this virtual network. And how we that understand in the practice, I can share my example here with my in Azure portal. For example, in that propose, I create the free virtual network with my resource group network security, and location is France Central in Visual Studio Enterprise subscription. That is my subscription, and for example, I defined address space 10.1.0.0/16 in, and actually I also define my subnet here. I can create subnet in very easy way with my subnet ID and the name that is, for example, subnet 1, and the starting address is actually 10.1.0/24. That is class C subnet IP address. And what is my idea to see actually what is how we define peering between for example virtual network 1 and virtual network 2 and virtual network 1 and virtual network 3. And I can see here peering, and you can see how I fully synchronize between this virtual network, and how we add. For example, I can define virtual network 1 to virtual network 3 in peering link name. What is my virtual network deployment model? That is resource manager with my subscription and my virtual network. For example, that is virtual network 2. And okay, I have previously defined, but my idea is to explain what we're doing now. Remote virtual network peering settings is allowed between these two network, and I also define a connection between virtual network 3 and virtual network 1 to allow virtual network to access locally virtual network peering settings, and that is very, very easy to understand. And I, after that, fully synchronize these two virtual networks with peering status connected. Virtual network peering actually enable how we seamlessly connect two or more virtual networks in Microsoft Azure, and the virtual network appear as for actually connectivity purpose, and that is approach how we understand this process. But firstly, we must create virtual network plan, and peering is actually very, very easy. And when we know what is the hub and spoke topology in Microsoft Azure, when we know how to create virtual network plan and peering, it is very to understand this process, how we actually configure network security groups. Network security groups can be filtered from many other resources in Azure Virtual Networks, and with network security group contains security rule to allow or deny inbound network traffic or outbound network traffic from several types of Azure resources. And of course, for each of these rules, you can specify source, you can specify destination. You can see now here I can go in network security groups here, and when I create, for example, one of network security group, the first parameter is subscription, but after that I can define some network security group I previously defined, this resource group, and for example network security group 01 in my France. Centrally I can define some tag, for example created by for Sentinel purpose, and I am, for example, owner of my network security group, and after that, and I can validate it and create, of course, network security group in very easy way. Network security, I can go in the resource, and what is actually you can see a lot of in overview tab actually essential with resource group, my location, subscription. I can define priority with inbound security rules I mentioned before, or outbound security rule, and you can see default inbound security rule like 65.0.0.0 that to allow virtual network inbound from any port, from any protocol. Source is virtual network, destination is a virtual network, and that is allowed by default. But when we use actually process from any port, from any protocol and any source and destination, that is denied by default. What is important? Name, that is actually unifying identifier. Direction. In direction, we can specify whatever is traffic is unbound or unbound. Priorities, if multiple rule match the traffic, actually rule with the high priority apply. That is important. In access, I can specify what traffic is allowed or denied. And source IP address prefix identify where is the traffic originated from. It can be based on single IP address, but in the range of IP address in Cedar notation, or some asterisks. When we define secure inbound, for example, I can see this asterisk, but in source, I can see IP address, my IP address, service tab, application security group for any destination, or service tab or application security group. I can choose my services like HTTPS, like SSH, RDP, FTP, etc. And I can define my destination port range from any protocol, from any TCP or UDP of SMP version 4. Action can be allowed or denied with some priority, with the name and description. And that is very easy to understand. The destination port range, for example, specify destination port using either to single port number from 1 to 65,530 and range of port, for example, 200 to 400, or asterisk to denote all possible port. Protocol is actually specified protocol that match the rule. It can be UDP, TCP, or asterisk also. And that is, and after that we can customize network security group. When I create custom role, I can use default tags in the source and destination, IP address prefixes, for example, to specify predefined category of IP address. For example, one of categories is internet. This tag represents internet IP address. The second is actually virtual network. Virtual network with the point of tag identify all IP address in the IP range in the virtual network defined. Also includes IP address range, for example, for on-premise networks. When I define local network for virtual network, and I can use load balancer tag specify default Azure load balancer destination. And when I design network security group to isolate some virtual networks in security zone. For example, I can use this approach on-premise infrastructure does. I can apply network security groups to subnet, which allow to create some protected screen subnet or DMC, and I can restrict traffic actually flow to all machine assigned with that subnet. And I can create an NSG as a resource in the resource group, but I can share them to other resource group also in my subscription. Deploy network security group. By default, I can create 100 network security group per region per subscription. I can raise the limit by 400 by contacting Azure support, and I can apply only one network security group to the virtual machine, subnet, and or network adapter. That is very important to emphasize. But default, I can have up 200 rules in the single NSG, and I can raise the limit 500 by contacting Azure support, and I can apply network security group for multiple resources. That is very important to understand. All virtual network is actually all virtual network interface is additionally associated with virtual machine security group like this. In this example, for inbound traffic, the subnet NSG here is evaluated first. Any traffic allowed through subnet NSG is then evaluated by virtual machine NSG, and the reverse is applicable for outbound traffics with virtual machine NSG to being evaluated first. Any traffic actually allowed through virtual machine NSG like this in this example is evaluated by subnet, of course, NSG. This allows for granular security rule application to help secure and protect actually my Azure resources to make sure the NSG planning is a standard operation procedure. That is actually SOP for my deployment. I can also I can have more rule on subnet as NSG, allowing internet traffics or restrict access for specific virtual machine by deny access on virtual machine network security group, and that can be applied for outbound traffic. That is very important to understand. Default inbound and outbound rule allow network traffic and load balancer all other traffic deny. How traffic is evaluated, I explained previously, but we have a lot of different approach. But I mentioned before, network security implementation is actually when we connected different network security group with the network identifier card. All of this network security group is evaluated independently for subnet and NIC. And I can more rules. I can define many pre-configured selection in SSH, in RDP and FDP, troubleshooting with the security rules link, and etc. And that is very good example. I can also define my Azure Firewall between internet and actually my virtual network one in East US region. I can define one route table with the route default route 0.0.0 from any port with my actually IP address 10.10.4. I can define private DNS zone with link for free virtual machine in order to enable auto registration. And you can see I previously explained I can define two peering between virtual network 1 and 2 with the regional approach, and global peering between virtual network 1 to virtual network 3. And that is a good example. And I can assign also application security group between virtual machine and 2, and in order to control inbound, to allow or deny with the specified network security group 1 from any and port actually 1 for free for TCP approach. And definitely I can use different network security group rule I mentioned deploy, and deploy network security implementation. Network security implementation, virtual machine is placed inside Contoso subnet, and Contoso subnet is associated with subnet NSG. In this example, for inbound traffic, subnet NSG is evaluated first. Any traffic allowed through subnet NSG is then evaluated by the virtual machine network security group. And several arresters you can use in that approach can be deployed into Azure virtual network. You can associate, of course, 0 or 1 network security group to each network security network subnet and network interface in virtual machine. You can use different approach and different scenarios for how network security group might be deployed to allow network traffics and from the internet over TCP port. TCP port actually, for example, 18. And I also share with you this approach because that is interesting. How we understand. Yes. And actually, for inbound traffic, all process the rules in network security group here. I can zoom again for better visibility. Yes. For example, virtual machine 1. Security rule is network security group R proceeds. SYN is associated here to subnet 1, and virtual machine is subnet 1, and unless you create a rule to allow port 18. Inbound traffic is denied by any all inbound default security rule, and never evaluated but network security group 2. That is clearly, you can see clearly here in diagram. To allow port 18 into virtual machine, both network security group 1 and 2 must have a rule that allow port actually 18 from the internet. For example, virtual machine 2, the rule in network security group 1 are proceed because virtual machine 2 is also in subnet 1, but since virtual machine doesn't have network security group associated its network interface, it receives all traffics here through network security group 1, or is denied, all traffic denied by NSG 1. Traffic is either allowed or, of course, denied to all the resources in the same subnet when the network security group is associated to the subnet. That is very important to understand. In the case of virtual machine 3, since there is no security group associated to subnet 2, traffic is allowed in the subnet and proceed to NSG 2 because this network security group is associated to network interface, and that is attached to virtual machine 3. And finally, virtual machine 4, traffic is allowed to virtual machine 4 because network security group isn't associated to subnet 3, but all network traffic is actually allowed through subnet network interface if they don't have NSG associated to them. For all or for all outbound traffic, as Azure proceed the rule in energy associated here for the network interface. First, that is very also understand, for example, virtual machine 3, I don't know, if energy 2 here has security rule here, deny port 18, traffic is denied. But if energy 2 has security rule that allow port 18, then port is allowed outbound to the internet, since network security group is not associated, for example, subnet 2. And you can define some intra-network subnet, but actually that is the approach how we understand here and how we work with actually inbound and outbound traffic when we have some traffic is evaluated. But I mentioned here application security group. Application security group, how we build actually network security group. Quick review of security group remind me I can filter, for example, network traffics and from Azure resources in Azure virtual networks, which energy network security group contains security rules to allow or deny inbound network security traffics. But in application security group's approach, I can configure network security as a natural extension of application structure. I can define the group virtual machine and define network security policy based on this group, and I also can reuse security policy to scale without, for example, some manual maintenance of explicit IP address and everything. And application security group actually helped me in that approach. Application security group have some constraint. They are limited to the number of ASG. You have can you have in subscription? In addition, another limit related, you can specify this group as a source and destination, of course, in security rule. All network interfaces assigned to the application security group must exist in the same virtual network, like in this approach, and then the first network interface assigned to the actually application security group. And of course, I must have a single management experience, increase limit to multiple dimension, great level of simplification, and seamless integration with architecture. And I also enable, like this approach, some service endpoint. Why service endpoint is important? Because in many cases, I can define virtual network service endpoint to provide identity of my virtual network to Azure service, and once service endpoint is enabled in my virtual network, I can secure definitely Azure service resource to virtual network by adding virtual network rule for some resource. And all Azure service traffic from my virtual network actually use public IP address as a source IP address. With service endpoints, I can define service traffic switch to use virtual network private address as a source IP address when accessed to Azure service from the virtual network. Like in this approach, that the switch actually allows to access service without need reserves public IP address using IP firewall. And that is in many cases I can use service endpoints in virtual machine access storage account restricts access, for example, for virtual machine private IP address, and that is how we actually understand. And why I use Service Employee. The first reason why I use Service Endpoint to improve security of my Azure service resource. Virtual network private address space can be overlapping and so cannot be used to uniquely identify some traffic originating from the virtual network. Optimal routing is very important. Optimal routing, today any routes in my virtual network force internet traffics for my on-premise and virtual appliance. That is actually how we understand force tunneling, and that is also force Azure service traffic to take the same route in internet traffic. Endpoints always take service traffic directly from the virtual networks and actually to the service to Microsoft Azure backbone network, keeping traffic actually of Azure backbone network allow me to continue auditing and monitoring and outbound internet traffic from my virtual network through force tunneling without impacting service. Set up with less management overhead, what means if no longer need some reserves like public IP address in my virtual network to secure Azure resource through IP Firewall. And what is important with the service endpoint, the source IP address of the virtual machine in subnet for the service traffic switch from the using public IP address to using private IP v4 address, and existing Azure service firewall using Azure public IP address will stop working with the switch. And that is very important to understand this. I can, in very easy way, to configure service endpoints to provide benefits for different scenario when we talking about appearing connected multiple virtual network, when we discuss about filtering outbound traffic from the virtual network to Azure service, like this approach, and I can use securing Azure resource for this approach to service deploy directly from the virtual machine networks. Sorry. And this traffics from the Azure virtual machine, actually, this is for managed and unmanaged disk that it isn't affected by service endpoint routing change to Azure storage. From on-premise perspective, I can use ExpressRoute public peering on the internet access to network address translation IP address from the public to private IP address. And actually, that is very, very important, that how we understand. And I can add some service for endpoint, for example, for Microsoft storage. Any service endpoint can take up to 50 minutes to complete, but you can use actually different approach for that. And I can deploy also, when we're talking about private link, Azure private link is very important in the point of view network security. On how we approval call flow, like this flow model in the diagram of these slides, where in private link service customer can request connection to service provider for consuming some services, and service provider can then decide whether to allow the consumer to connect or not, of course. Azure private link enable service providers to manage private endpoint connection of some their resources. I can use private connectivity to service on Azure. I can use integration from on-premise and peering network, and the traffic remains on the Microsoft network with no public IP address. And when I have some security incident, for example, service provider has always have option to choose from the all private endpoint connection to approve, for example, to reject or remove. And I can manage private endpoint connection on Azure platform as a service resources. Azure portal actually is preferred method for managing private endpoint, but During security incident, I mentioned with my network only MAC addresses will be accessible. That is very, very important, and one of the reasons why we used this approach. And many other approach when you're talking about, for example, Azure Application Gateway, that is a web traffic load balancer, and I can enable manage traffic from my web application. Example in this diagram, in traditional load balancer, I can operate with transport layer, with OSI model, with TCP or UDP, and the route traffic based on source IP address and port, of course. I can use internal load balancer, I can use public IP address like this via port 18, or when I can use internal load balancer in order to balance a multi-tier application by using port public or internal load balancer. It is very easy to understand, but application gateway now, I can make a routing decision based on additional attributes or HTTP request, for example, URI PET, or for example, I don't know, host read headers, for example. I can route traffic based on incoming URL. So if some image in the incoming URL, I can route traffic to the specified set of servers, pull, configure it to the image. If some video is URL traffic is routed to another pool that is optimized from the videos, and that is actually how we understand the application gateway include for a lot of features like SSL TLS termination, like auto scaling, like zone redundancy, static VIP. Web Application Firewall is actually here as a service that provides centralized protection from my web application, from common exploits and vulnerability. Web Application Firewall is based from OWASP project core rule set for many other Win version, for example, 3.0 and more. I can use redirection. That is interesting for many scenario. For many web application is to support automatic HTTP or HTTPS direction to ensure all communication between application and users, of course, over encrypted path, multiple-site hosting, URI-based routing, and actually session affinity, cookie-based session affinity. WebSocket and HTTP traffic provide actually native support from this protocol, and that is how we understand this approach, and many others with the point of view features. Sizing is very important with the point of view application gateway standard can be configured for auto scaling or fixed size deployment. New application gateway version 1 SQ deployment can take about 20 minutes to provision. Most deployment can use this version take around 6 minutes to provision, but actually that is how we understand this process. Web application firewall I mentioned provide many possibility, but that is actually how we provide centralized protection of my web application from common exploit and vulnerability. And the web application is increasingly target, but malicious attack that exploit commonly no vulnerability. SQL injection is a good example. Cross-site scripting is also a good example among the most common attack scenario. And the central question is how to prevent such this attack in application code. It's challenging. I can require rigorous maintenance. I can require patching. Of course, patching is most important, and how to found a way to monitoring multiple layer of application topology. Centralized web application firewall helps me to better understand security management much simple, and this approach with web application firewall also gives application administrators more possibility to better understand protection against threat and intrusion capability. WAF can be deployed with Azure Application Gateway, of course, Azure Front Door, yes, Azure Content Delivery Network with the CDN service from the Microsoft Web Application Firewall or Azure CDN is currently under, and actually feature that is customized from each specific services. I can configure and manage a lot of different services like Azure Front Door, that is actually a assembler for global routing, works or HTTP or HTTPS and use split TCP-based NICS protocol. Front Door ensure that actually your end user promptly connect to the nearest front door point of presence. So I can use routing from client request to fastest and more available application backend. And of course, you have different, you can use different approach. Application backend is any internet-facing service hosted inside or outside Azure. Front Door actually provide a range of traffic routing method for backend and health monitoring option. But you can use failure model like traffic manager. Front Door is designed for failures, including the failure entire Azure region, and protocol support IPv6 or HTTP/2 traffics. I can use, for example, Azure Front Door, and I can define primary region from my Azure function application in the database, and secondary region from Azure function application and database, and I can use different features, including Front Door, in order to accelerate application performance, to increase application availability. With the smart health probes, for example, that is very, very good example. And I can see here I can use Contoso domain from each location in order to access with the Microsoft Global Network with the free region like this. I can use different approach feature with the Front Door, like TLS termination, multiple site hosting, URL based routing, increase application availability with smart health probe. I can use monitoring my backends definitely for both latency and availability in order to provide instance authentication failover with backend goes down. And custom domains, when I use Front Door to deliver some content, I can use custom domain if is necessary. If I would like, for example, own domain name to visible in my Front Door URL. Application layer security I mentioned, URL redirection I'm also the previously mentioned, and URL rewrite. It is very interesting because Front Door support this option. In order to allow, I can configure optimal custom forwarding path and use some when constructing to request to forward to the backend. And actually, ExpressRoute is also good approach. I can use ExpressRoute in many cases because that is a direct private connection like this in this approach from my virtual area network, wide area network that is not over the public internet to Microsoft service, including Microsoft Azure. site-to-site VPN traffic, actually travel encrypt over the public internet, and be able to configure site-to-site VPN also. And ExpressRoute connection from the same virtual network is several advantage. I can configure site-to-site VPN, actually is a secure failover path to the ExpressRoutes, or use site-to-site VPN to connect to sites that are not part from my virtual network, but that is connected to ExpressRoute. I can use primary connection and secondary connection to my ExpressRoute circuit when I connect with the Microsoft Edge and when I access from Microsoft 365 SQL for other Microsoft services here. And in the blue option, I can use private peering for my virtual network, and actually that is very easy to understand. I can use service provide model for approach in order to connect providers. Many offer one and more connectivity model to cloud exchange, co-location, point-to-point internet connection, the service provider model, and to any IP VPN connection from when I connected via ExpressRoute to Microsoft Azure service. And I can use Microsoft Route Direct, also option direct model with ExpressRoute in order to connect ExpressRoute sites and Microsoft Azure services. I can connect directly into the Microsoft global network with a peering location, distributed across the world. That is very easy to understand. I can use different service provider with the statistic ExpressRoute Direct. In this table, you can use actually this approach from when, for example, require 100 gigabytes or 10 gigabytes infrastructure for 1 gigabyte per second, how we optimize for single tenant, how integrated with 100 of provider, including internet and MPLS. I can use service provider to enable fast on-bound connectivity into existing infrastructure with the ExpressRoute using service provider. And this actually circuit with this queue describe for different size here and model physical port pairs on 100 gigabyte or 10 gigabyte only. I can have multiple virtual circuit with a different statistic. It is very easy to understand because ExpressRoute I previously mentioned direct support for both Q virtual LAN tagging and .IQ virtual LAN tagging. When we mention and when we discuss here with the ExpressRoute Direct, because that is give me ability to connect directly into the Microsoft global network at peering location, distribute across the world, provides actually dual 100 gigabyte per second or 10 gigabytes per second connectivity, but support active to active connectivity at scale. And I can use granular control this circuit distribution based on business unit, and actually lot of other examples. Okay, now we are continue with actually Azure Firewall. Azure Firewall have two options. I can open my actually I prepare my Azure portal in order to better understand this approach. But how we deploy Azure Firewall, I can create some workload subnet in the job subnet, some my virtual machine, and I can use for that approach some jump server or workload servers in order to connect with the custom route, with the network rule and application rule with my DNS lookup and ping. And I can create a firewall network rule to allow traffics. For example, different approach. I can configure Azure Firewall in actually two options. With Azure Firewall standard, with the hub and spoke approach, I can use a central point connectivity hub to connect from my on-premise network and Azure, and I can use configuration actually for base of L3 to L7 connectivity policy. I can use Microsoft Threat Intelligence, no malicious IP address in FQDN. But when I use Firewall Premium, I can include standard firewall capability and other different premium features like TLS inspection, like IDPS, URL filtering, web category, and I control traffic. Traffic is denied by default from the public internet, but I can define a lot of network application security groups, and I can create this approach. Yeah, I can be asked to install firewall in order to help my organization control inbound and outbound network traffic, for example, which is important part of overall network security plan. And I can define first virtual network with workload subnet and job host subnet, virtual machine from each subnet, custom route to be ensured for my outbound workload traffic from what subnet must be used. And firewall application rule is only allow outbound traffic from, for example, Google.com or Bing.com. Firewall network traffic allow external DNS and server lookups in order to better understand this process. In this actually approach, for all resources, I can use some region, for example, in East US, to better understand. And when I configure Azure Firewall, my organization needs to also allow Windows Update network traffic through the firewall. I can use application rules to define FQDN that we access, for example, from subnet. I can use usage FQDN will be appropriate to allow Windows Update network traffic for that approach. And when I use, for example, Azure Kubernetes service, I can create firewall with the principle as privilege. It should be applied how traffic can flow between pods in Azure Kubernetes service cluster. Network policy feature in Kubernetes define a rule for ingress and egress traffic between pods in the cluster. And that is actually explain how I create network policy, but I also use actually this approach with different other scenario. I can use for just-in-time access, for example, enable security center, use center security groups, and Azure Firewall rules in order to restrict access to management ports, so they cannot target it, but attackers. I can use definitely in many cases this approach, but Azure Firewall Manager is also most important. With the Azure Firewall Management, I can use also hub and spoke architecture approach. I can define, for example, two spoke with my virtual networking in order to connect my on-premise traffic filtering to Microsoft Azure, and of course I can use L3 for 12.7 policies. And of course, when I use force tunneling, I can push all internet traffic to specific nets for on-premise device. For example, I can use network address translation for network application traffic filtering rule in order to allow inbound and outbound access. I can use FQDN tag. I can use separate firewall subnet for static public IP address, and a lot of different approach. And actually, Azure Firewall implementation is easy in this approach in order to control all inbound traffic. Network access, that is important part of a network security plan. I can configure application rule here to define fully qualified domain names, can be accessed from the subnet, but I can define also network rule for source address, for protocol destination, port destination IP address, and with premium, I mentioned here in the previous slide. Here, yes, I can control, for example, TLX expression in order to decrypt inbound traffic, process of data, encrypt data and send to the destination, URL filtering, that is extend Azure Firewall FQDN filtering capability to connect entire URL. For example, www.contoso.com ASC instead of www.contoso.com. And I can define different web category in that approach in order to control all traffic. But network traffic is actually like this, is subjected to configure firewall rules when I route for my network traffic to the firewall as a subnet default gateway. And I can use, I mentioned, fully qualified domain name FQN tag to manually allow Windows update network traffic to the firewall. I can need to define multiple application rule per Microsoft documentation, and I can use infrastructure qualified domain name also to compute access to storage platform in Azure repository. I can monitor Azure Firewall using firewall logs. I can also use activity logs for audit operation on Azure Firewall resource. And threat intelligence-based filtering is also interesting. I can enable on the firewall to alert any traffic from my known malicious IP address and domains. VPN force tunneling is also interesting in order to redirecting internet-bound traffic back to the company on-premise infrastructure for inspection and audit, and I can use internet-bound traffic from virtual machine always from traverses from to Azure network infrastructure directly to the internet without inspection and audit, and I can use different approach in this option. Virtual private network consists of remote peering sense to private data security. I can use site-to-site VPN tunnels to encapsulate data packet with the normal IP packet for forwarding over IP address, using encryption to ensure privacy and authentication to ensure integrity of data. And I definitely have a lot of options. This diagram actually depicts how force tunneling works. Actually, I can configure force tunneling in Azure via virtual network user-defined routes. That is important also, but front and subnet doesn't use force tunneling. The workloads for end subnet can continue in order to accept and respond from the customer request, but come directly from the internet. That is very important, and definitely this allows to restrict and inspect internet traffic from virtual machine or cloud service in Azure while continue to enable multi-tier service architecture. I mentioned user-defined network virtual appliance, user-defined routes override default system route and are associated with the subject. I can define default gateway subnet in order to connect with public DMZ and web tier. Actually, here network virtual appliance control the flow of the network traffic from the one network to another. In green side, I can request to Azure workloads. I also request from the Azure workloads with the internet clients. I can use public IP, but control associated with the network virtual appliance for that approach. And that is very easy to understand this approach. I can configure force tunneling in Azure via virtual network user-defined routes in order to redirecting traffic from on-premise site that is expressed by default route on the Azure VPN gateway, for example. And of course, this example use user-defined route in order to create a routing table to first and actually add. I can use user-defined route as a custom route in Azure. I mentioned but in this diagram, user-defined route are used to direct traffic from the gateway subnet and the web tier to the network virtual appliance, and that is very important to understand this approach like this. Okay, that is all from my side from this session. Thank you for your attention, and see you on the next or some of the next session. Have a nice rest of the day, and goodbye.